This podcast will cover the notes in your packet, Unit 1 measurement, on physical and chemical properties of matter. So first we've got to talk about some definitions. What is chemistry? The most standard textbook definition is the study of matter and its changes. So matter is anything that takes up mass, that has mass and takes up space. And be careful because this includes gases, which we can't see but are definitely still matter. Composition includes what an element is made of. And we'll talk a lot about that when we talk about atoms and electrons and protons and things like that. And then properties are what we're going to talk about now, and that is observations and characteristics of matter. Characteristics, what does it look like, and then observations, what do we see and what does it do? So physical versus chemical properties. Physical properties are what we're talking about now, and that includes color and taste, which we are not going to do in the lab, boiling point and melting points, density, which we're going to talk about extensively at the end of this unit, size, like size of particles and what are they shaped like. Chemical properties involve what the reaction or what the substance does and how does it react. How does it react with air and water and heat and light? So what does it do? And these involve chemical reactions, so we call them chemical properties. So for an example, we are going to look at aluminum and ethanol. So aluminum is a metal, and it's shiny and gray. Because it's a metal, it's malleable, which means we can move it around, and it's conducting, which is why it's used in things like pans. Chemical properties of aluminum: if we take aluminum and we burn it with oxygen, we can make aluminum oxide, which is a white powder. So that's what happens when we burn something, when it reacts with oxygen. So it's a chemical property. Ethanol is a liquid. It's clear and it's colorless. It boils really low, which is why it evaporates so easily. And it's flammable, which means it catches on fire when we have a flame near it, which is why we can use it in gasoline, because it burns, and that's a chemical property. So, intensive versus extensive properties, these are definitional things, and almost single thing that we talk about for properties is going to be an intensive property. What an intensive property is it doesn't depend on the quantity or the amount. Extensive property does depend on quantity. So intensive property, color doesn't change whether you have a little bit or a lot. Boiling point doesn't change whether you have a little bit or a lot, and all of these are going to be intensive properties. Extensive properties include mass, or how big something is, what the size is. Those are not things we usually talk about. So physical versus chemical changes. Physical changes are phase changes and changing of shape, but don't change the substance. So those are evaporating, freezing, melting, and condensing. Chemical changes are the things that we talked about. If something reacts, it burns, it rusts, it reacts, it decomposes. Those are all chemical changes because they're chemical properties. So if we try to visualize change on an atomic scale, what type of change and why, we're going to look at these two diagrams and talk about what kind of change and why that happens. So this first change is physical, because this over here is nitrogen, which is a gas or a liquid, and each N pairing is a nitrogen molecule, which is N2, but this interaction between them we call a bond. And over here we see that those bonds are still intact. We haven't broken them or made any new bonds. We have just rearranged the structure. We have rearranged it from this random assortment, which we call a liquid because it can move around, to this lined up structure, which we call a solid because it is very rigid. So going from a liquid to a solid would be freezing, so that's a physical change. On the other hand, if we look at this next picture, we've got magnesium down here, and we can see that it's a solid because it's all lined up, and it has bonds which are connecting everything. Up here we have oxygen, which is in the gas form because there's lots of space in between it. But we've got O2 molecules, and after it burns, we've made new bonds, which are the attraction between a magnesium atom and an oxygen atom, and we've broken some other bonds. So that is a chemical change. This last one down here is sort of debated, and I'm going to give you the argument that most books use. It says that when you take sodium chloride, which is table salt, which we know is a solid, and we put it into water, which is a liquid, what kind of change is that? So you've got sodium chloride, it dissolves in water, so we have a solution where everything is mixed together, and things are broken apart, so you can argue that it's a chemical change. But because if we take our salt water and we evaporate off the water, we are left again with solid sodium chloride. Because it is reversible, that is generally considered a physical change. So because it is reversible, we are going to call this a physical change. Notice that that can be argued either way, but this is what most books use. So here we're going to try something. There are some pictures, A, B, and C. So looking at A going to B, what kind of change is that? A going to C, what kind of change is that? Stop your recording and try it out yourself, and then restart and see how you did. So A to B is a chemical change because things rearrange. A to C is a physical change because the bonds don't break and form new ones. They just rearrange into a structure, like a solid. So do one more. What type of change and why? Again, stop the recording, try to do it, and then start it back up again and see how you did. This is a chemical change because the red and blue bonds are broken, and we have formed new red-red bonds here. Okay, states of matter, just to review this, you've probably seen it before, but solid, liquid, gas. Solid is packed close together, it holds its own shape, and that's shown usually by showing that it's a rigid structure. Liquid is also packed close together, but it takes the shape of the container. So it is a loose structure, or everything's moving around. Gases are fast moving, they're spaced far apart, and they also take the shape of the container. So to show their movement, we show these little whooshies here, spaced far apart, and they're definitely not lined up. Changes in states of matter are always physical changes. So if we think about gas, solid, and liquid, what is it called when we go back and forth between these three states? Label the arrows, and then stop the video, label the arrows, and then turn it back on and check and see how you did. So going back and forth between solid and liquid, solid to liquid is melting, and liquid to solid is freezing. Going back and forth between liquid and gas, going gas to liquid is condensation, and liquid to gas is evaporation. And going back and forth between solid and gas, which is not very common, solid to gas is called sublimation, and then gas going straight to a solid is called deposition. And this is the one that some people aren't familiar with, and it always shows up on tests, so make sure that you remember that one.